Good morning, ladies and gentlemen. Today is Chapter 3, Lesson 7, Factors and Multiples. Today, in order to complete this lesson, we need our multiplication table, and we need page 175. Okay? Factors and multiples, kiddos. Believe it or not, you have already played with factors and multiples when you have participated in Mountain Math. So looking at this, number 3, number 4, and number 5 all deal with factors and multiples. Number 3, you're looking for factors, and you're looking for factors to figure out if a number is prime or composite. We'll go a little bit more into that in a bit. Number 4, you're looking at factors to find something that you're going to need when you're working with fractions. Okay. So, and number 5 is you're looking for multiples for a strategy when also working with fractions. So what we're doing here is we're preparing you for how to operate with fractions. So factors and multiples are going to be really important for you. So as I said, page 175 and your multiplication table will be what you need from your binder for this lesson. Okay. We are going to list the multiples, all 6 of these problems, and the factors of these problems here. All right, so factors, right? The first thing with factors is all numbers have 1 as a factor, 1 times itself, right? All numbers have 1 as a factor. Okay, that's your first clue, right? All numbers have itself as a factor. Okay, so let's look at your independent practice. Okay, and let's go to number 6. Okay, pause this tutorial and see if you can't use what you know from Mountain Math to use your multiplication table to list the factors of 7. Go ahead and pause the tutorial now and give that one a shot and check your answer up against mine and listen carefully to the explanation. Okay, so number 6, we have to find the factors of 7. Okay, now when we go and we find the factors using a multiplication table, what we want to do is go into the multiplication table and start looking at the answers. So we want to find 7. In order to find 7, then we can make the factors. The factors are found along the sides of the multiplication table. Okay, so this is a list of your factors here, and across the top you also have a list of your factors. So let's dive in here. Let's find number 7. Okay, boom, I found a 7. How did I make that 7? How is that 7 made? Well, go up to your top factor, 7, or you can go over to your side factor here, 1. But when you do that, 1 times 7 is the factor pair. So the first step is list your factor pairs. You got 1 times 7. Yep, and I'm listing it right here on the worksheet. Okay, just finding a place to put it. Factor pair number 1, 1 times 7. And I found another 7 over here. How did I make that one? 7 times 1. So it's the same factors. I do not need to list the same two factors again. So let's look here. What did I just find? There's no other 7 on my multiplication table. Okay, just these two 7s. Nothing else. No. Going along, it's just these two 7s made by 1 times 7. So let's look at what I just said here about factors. All numbers have 1 as a factor. 7 has a 1 as a factor. Put a comma. Okay. All numbers have itself as a factor. Well, we found that in looking for the factors of 7, 7 is a factor of 7 and 7. But because we didn't find anything else for 7, this is what number 3 in Mountain Math is talking about, right? Is the number prime or composite? So I'm kind of giving you a double lesson here. But 7 is a prime number. Okay? 7 is a prime number because it only has 1 and 7 as a factor, or it only has 1 and itself as a factor, prime number. Well, then the opposite of that is look at number 5. Okay, let's find the factors of 4. Now, another idea, another strategy, another thing to remember when you're listing factors. All even numbers have 2 as a factor. Okay, all even numbers have 2 as a factor. So let's look at number 4. 4 is an even number. Okay, it can be divided evenly into 2 groups. So what did we say? All numbers have 1 in itself as a factor. So the first factor pair we list is 1 and itself. Okay, 1 times 4. We could do that for 14 and 28 and 30 and 35, and we'll do that, right? In fact, let's do that. 14 has a factor pair of 1 times 14. 28 has a factor pair of 1 times 28. 30 has a factor pair of 1 times 30. And 35 has a factor pair of 1 times 35. Okay, so we've gotten all of them started. We have 2 factors for each of these numbers. Back to the even number. If all even numbers have 2 as a factor and 4 is an even number, well, 2 times what equals 4? I have a multiplication table for that. Find 4. 2 times 2 equals 4. There's another 4 right there. 4 times 1 equals 4. Oh, there's another one. 4 times 1, right? Or 1 times 4. Okay. So you got your 4's in there. And we found that 2 times 2 is a factor pair of 4. I put in parentheses just to group the numbers together. Otherwise, it could get a little messy once you start listing all these factor pairs. Those are the only factor pairs of 4. Okay, it's the smaller the number, the less factors it's going to have a lot of times. So now I list these from smallest to biggest. 1 being the smallest. Then I have a 2. This is a double. I only need to put the 2 once. And 4. 1, 2, and 4 are the factors of 4. Okay, because there was more than just 1 and itself, there's a 2 in there. This is called a composite number. Okay, so going back to number 3 in Mountain Math, if you're being asked is the number prime or composite, now you know why. If it has more factors than 1 in itself, 2 in this case, it's a composite number. Over here with 7, we only had 1 and 7, so 7 became a prime number. And I know that simply by looking at the multiplication table. Okay. All right, so let's see here. Next one is 14. So let's find the factors of 14. We already know that 1 times 14 is the first factor pair, right? 1 in itself. 14 is an even number. It's got an even digit in the ones place. So 2 times something will equal 14. If I come over here and I know it's 2 times something, I can scan 2. Boom, there's 14. And 2 times 7 is 14. Let's see if there's any other factor pairs. I'm just scanning. 14 times 1, already got it. 7 times 2, already got it. No 14 here. It goes from 12 to 15, 12 to 16, 10 to 15, 12 to 18. Oh, boom, there's a 14. But we already have it. 7 times 1 is, or excuse me, 7 times 2 is 14. Then we have 8 to 16. No 14. No 14. Oh, there's a 14. 14 times 1. And we already got that too. So we're done. 1 times 14 and 2 times 7. Let's list them from least to greatest. 1, 2, 7, and 14 are the factors of 14. This is definitely a composite number. Okay, let's find the factors of 28. We did. The first one is 1 times 28. See, these parentheses can sort of keep your numbers together, keep them organized. 1 times 28. 28's an even number. 8's an even digit. So we have 2 times something is 28. Let's see if we can't use this big old multiplication table here. Sometimes you're going to have to think of some different strategies to find 2 times what equals 28. But we have a multiplication table that gives us a large enough factor. 14 times 14 times 2 is 28. Okay? Or 2 times 14 is 28. Okay? 2 times 14 is 28. Let's see if we can't find any other 28s in here. Scanning for a 28. Didn't see it. Oh, there's a 28, but that's that 2 and 14 we just got. 3, 6, 9, 12, 27. Yeah, no 28. Come down here. Ooh, there's another one. 4 times 7 is 28. Another factor pair. Woohoo. And just for giggles, let's see if there's any others. 7. Oh, there's another one. 7 times 4. We have already got that. No 28. No 28. Nope. Ooh, 14 times 2. We already got that. All right. We are all done. 1 times 28, 4 times 7, and 2 times 14. So we have 1. Okay. 2, 4, 7, 14, and 28. That was a good list of numbers right there. All right, good list of numbers. Going on a fact hunt looking for these factors. 28 is definitely a composite number. Okay. All right, 1 times 30 is our first factor pair of 30. Let's see if there's any others. Let's see. Yeah, well, we don't have a factor size of 30, but we know that 1 times 30 would be all the way down here. Okay. All the way over here somewhere. But we already got that. How about 2 times something? 2 times 15. 2 times 15 is 30. 30 is an even number, so we know that 2 times something is a factor pair. 2 times 15. Okay. 30, I know 3 is a factor of 30 because 3 times 10 is 30. Getting these factor pairs written down. Some of them have a lot more than others, so keep them organized. All right, let's jump back into our multiplication table here. What do we got? Any more 30s? There's 28, 32. Boom, there's a 30. 5 times 6 is 30. 15 times 2, 3 times 10. Just for giggles, any others? There's 6 times 5, is that 30? We've already got those factor pairs. No 30, no 30. Ooh, the 10 times 3, already got that. Ooh, 15 times 2 is 30, and we have already got that. We are all done. We've got 1, 2, 3, 5, 6, just listing them from least all the way to greatest. 10, 15, and 30. All right, that's a good one. That's okay. Factors, we got one more for factors here. Okay, the next one is 35. Okay, we've got 1 times 35. Okay, and this brings me, look at the numbers 30 and 35, brings me to another pointer here to remember about factors. Okay, if the number has a 0 or a 5, if it has a 0 or a 5 in the ones place, okay, 5 is a factor. For example, looking at 30, it has a 0 in the ones place. I knew that 5 was a factor, okay? Because 5 times something is going to give me a number that either has a 0 in the ones place or a 5 in the ones place. Because this has a 5 in the ones place, I know 5 is a factor. Because it's an odd number, I know that 2 is not a factor of 35. So let's just do some skimming here in our multiplication table. Okay, looking for 35, looking for 35, looking for 35, 32, 36, boom, 35. 5, like I said, if it has a 5 in the ones place, 5 is a factor, times 7 is 35. Okay, and we can take a look. Anything else? Straight to 36. Boom, there's 35. 7. That's 7 times 5. I do not need to write that because I already wrote 5 times 7. Yep. Looking for 35. Okay. We have found the factors of 35. 1, 5, 7, and 35. Okay. So look, 9 and 10, those are heavy with factors, right? The only prime number we found was the number 7 because it only had 1 in itself. All these other numbers, okay, even 4, it's got 3 factors. Okay, it's got more than 1 in itself. Is also a composite number. Okay, these are all composite numbers here. Okay, the world of factors, kiddos. Your factors choices are these numbers along the vertical and the horizontal of your multiplication table. All right. Now, let's list out some multiples. Okay, multiples are going to be a little more approachable, right? Because all you have to do here is find the factor, right, on your multiplication table and list its multiples. In this case, our directions say list the first 5 multiples, okay? Just the first 5. Now, math asks you to list the first 8 and then put a star around that number. Hardest thing you'll do in 4th grade, put a star around a number. Okay, let's find the multiples of 1. This one's going to go a little faster. First 5. Looks like there's 1. So let's find the multiples. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Okay. Now let's find 3. Okay. Find the factor 3. Okay. These 3s. The factor 3. Here it is. Or here it is. You can go along the horizontal. You could go down the vertical. But the first 5 are 3, 6, 9, 12, and 15. 3, 6, 9, 12, and 15. Okay. The multiples of 5. Make sure you're pausing this video. Give that one a try. You know how to skip count by 5s. 5, 10, 15, 20, 25. There we go. So, sorry I didn't do this before, but you got 5 and 6 and 7 and 10 and 9 and 8. We're doing them all. Okay, doing them all. The factors of 7, find 7. 7, 14, 21, 28, 35 are the first 5 multiples of 7. 7, 14, 21, 28, and 35. The first 5 multiples of 8. 8, 16, 24, 32, and 40. Times 5 is 40. And the first 5 multiples of 6. Let's find the 6 up here. We'll go down the vertical. 6, 12, 18, 24, and 30. 6, 12, 18, 24, and 30. Okay. Alrighty. Now, what do we got here? 17 and 18. Tell the total number modeled by each array. Right? So 2, 4, 6, 8. 8 total. Right? Then find the factors of that number. Now let's work backwards. What do we have here? We got 8 total. So what are the factors of 8? Well, we got 2 rows of 1, 2, 3, 4. So we know 2 times 4 is an option. All right. Now, maybe we're not seeing it here. Go back to your multiplication table because you got 8 total. Let's find 8 in the multiplication table. Boom. 1 times 8. Got it. 1 times 8. And let's see here. Oh, there's another 8. 2 times 4. Got it. Wait, 4 times 2. Got it. All right. And then 8 times 1. We've got the factors of 8. So you can either do 2 groups of 4 or 1 group of 8. All right. That's the way that you can organize those arrays. So we'll list it from least to greatest. 1, 2, 4, and 8. 8 is definitely a composite number. All right, kiddos, let's find these. What do we got here? What's the total? All right, there's a number of ways to look at it. You got 3 rows, 5 in each row. I anticipate 15. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5, 10, 15 total. What are the factors of 15? And if we look at our cheat sheet here, right? All numbers have 1 as a factor. All numbers have itself as a factor. Put it down. 1 times 15. Okay, what do you have here? You got 1, 2, 3 rows, right? With 5 rows in each, or with 5 circles in each. So 3 groups of 5. You could rotate it and have 1, 2, 3, 4, 5 groups of 3, but we already have those 2 factors. The factors of 15 are 1, 3, 5, and 15. All right, kiddos? Alrighty, that is the world of factors and multiples.